Hey, hello guys. I really want to make a video about this amplifier. I was not taking this really seriously, but I decided to continue, and I be like, well, why not? So many of you like really high power amplifier boards, so I decided to continue. And I add the only difference about this circuit is that I just add 4 more pairs. I'm going to illustrate that with you guys. Wait for my program to is saving the. It's like the only thing I did is basically I add 4 more pairs. That's the only difference of this circuit. As you can see right now, that's the only difference. I add 4 more pairs. I was capable of adding 150 volt rail voltage. Maybe it's going to be really dangerous because that's a lot of voltage for the MOSFET. Because this MOSFET they can withstand 200 volts. I already checked on Mouser. Right now I'm going to show you the specifications of these MOSFETs. It's not a regular transistor. It's just a power MOSFET. Also, I was checking the paper size. So I was thinking I always use A4. Let me zoom here so you guys can see it better. ISO paper size for the printer. So in the past, I always was using A4 that is 210 millimeters by 297 millimeters. So I just find out that A3 size is 297 by 420 millimeters. So basically this is the illustration of the paper size. So I was using this one always, A4 paper size. So I figured out that A3 is the longest one. So basically I can share the PDF of this project. I don't have to worry about it, but you gotta find a really large printer so you can print out the artwork of these projects. So it's going to look like this. Let me take some of the TruePath stuff because I forgot to do that. Let me see. There you go. All right, it's gonna look like this. Here I had to make some changes because these are supposed to be jumpers. Let me change this to seal screen, and let's go 1 millimeter is fine. And then just to really illustrate the jumper. All right, let me change the other one. This should be a 1 millimeter, and turn this into a seal screen. And the other one, the top, is already fixed. I guess this is the. Oh, okay. I see. I see what happened here. Okay, let me. This is not the final project. This one is the final project. So it should be like this. But this one have the guy. So the only thing I gotta do is to make sure that I have the correct alignment of this. Okay, let me see. It should look like the other one. It's fine. It's fine. It is fine. So let me see. It's fine right now. Okay, this one should be 1 millimeter. 1 millimeter. So all right, 1 millimeter. Now we'll go to printer. It's going to look like this. So now that I know that the paper size is A3, I'm selecting right now is A3. I press OK, center this center out, and I don't need the outline, only the targets. There you go. Oh, I see what happened. See, yeah, I see what happened. So I need a line. So I really need a line so you guys know where to cut the PCB. Maybe I need to. Okay, no, don't worry about it. I will figure out that later. Don't worry about that. So let me see. Let me print that out to see how it looks on A4, A3. Sorry about that. A3 paper size. You need to know how large it is. All right. Now that that is done, I will check on my desktop to see how it's gonna look like. Oh, there you go, right here. All right. I guess this is the biggest. PDF file that I will share. Let me see. Everything looks fine over here. It is a pretty large PCB. This one is 325 millimeters by 100 millimeters. I already measured many times already, so right now I'm going to do it right now so you guys can see. I'm gonna use the ruler. I'm gonna measure from one corner to the other corner of the PCB so you guys can see how large it is. Okay, right in this corner, as you can see, probably you're not gonna be able to see, but it's 325 millimeters. That's a pretty long PCB. I was making some software simulation, and this amplifier with 150 volts. I'm not sure if that is safe. Okay, this one is 100 millimeters, so 320 size. I'm sorry about that. Size 325 millimeters by 100 millimeters. So I forgot to show you guys the specifications of the power MOSFET. And there is one thing that I need to change here. I forgot to do it. It's okay. Don't worry about that. I forgot to change this. It's supposed to be 9240. This one here is 9240. Just like the schematic. As you can see, IRFP 9240. So okay, let's just make it a little larger, 1.5, and then I'm going to duplicate this. It's 24.5. Tight arrange. There you go. All right, that's the way I do it. So now they are all labeled. 24. The bottom one MOSFET is a P-channel MOSFET. So okay, I gotta delete this because I forgot to delete the older one. So don't worry about that. Okay, there you go. Gonna delete that. And now they are all labeled, so let me do the same thing here. I'm going to fix this to make it larger. So MOSFETs. Yesterday I was working with the protections area of the circuit. This circuit right here, all these circuit that you see, transistors and resistors, it is part of the protection circuit of the output of the power amplifier. One example, this one here is the protection, and this one here will show the clipping in case the amplifier is clipping, so it will illustrate it on this LED. The PCB that have the protection circuit is this one here. Let me see if I can find it. This one is the one that protects the speaker. You can see you can install two binding poles, a positive and negative. It's a separate PCB, so you can place it on the chassis of your chassis case or your amplifier, or you can put it separate somewhere. So this is the circuit. It has the NTC 10K for the thermal in case the amplifier get really hot, so it will shut down. So here's the ground and protection. This one here is this pad here is the protection, and the other two are 12 volt AC, so to supply voltage to this circuit. Right now, just what I was thinking, that's why I have this thing over there. Let me go and fix the let me see. I was working with that for a few minutes ago. What is it? Okay, this one here. Okay, this one here. Let me fix this, make it larger. This one 1.5 millimeters. God damn it. Okay, 1.5 millimeters. Okay, 1.5 millimeters, and I need this to be duplicated to 8 more. So tight arrange. There you go. Okay. So now I have all identified as a power MOSFET. There you go. Okay, let's go to the data of this MOSFET. I always use Mouser to check the specifications. Okay, let's go Mouser. Oh, what the hell? Okay, Mouser. Let's go with Mouser of Puerto Rico. Hell yeah, I'm from Puerto Rico, guys. If you don't know that, Puerto Rico, man. So it's almost complete. I gotta keep checking to make sure everything is correct. I spent some time moving the components to making sure that to avoid the jumpers, as as possible. I was trying to avoid jumpers, but it's kind of difficult to do. Well, I only have this one have 5 jumpers so far. I have this jumper here. I forgot to put the letter J to identify that as a jumper. In Spanish is puente. It's puente. Okay, I'm gonna put it right here. It's okay. I'm gonna put it right here. J for jumper. Jumper, something like that. All right, there you go. So this one will have only 4 jumpers. These transistors is really important. I was making some just an illustration of the power board, but I was trying to place this transistor. It needs to track thermal temperature of the heat sink because it's part of the bias circuit. I already asked Mr. Mile. He told me that to keep those into the heat sink, they need to be attached to the heat sink securely to track temperature, so they can, the bias it will be adjusted according to the temperature. I was trying to place it closer to the one example. This is just an example. I was trying to place it closer to the power MOSFET, but I think it's fine because I think it might generate a lot of heat. I keep forgetting about find the part for the power MOSFET. So this one is the power MOSFET. BCHI semiconductor still have it so far. So let's go here. Oh wait, hold on. Sorry about that. This is the one, the power MOSFET. This is the information of the power MOSFET. Through hole, okay, one channel, N channel MOSFET. This is the N channel. Volt drain source breakdown voltage is 200 volts. So I was able to giving a supply voltage of 150 volt DC. That's a lot of voltage. ID current, continuous drain current, is 20 amps. Holy shit, that's a lot. So power dissipation is 150 watts right now. N channel, okay, so that's why I decided to add more pairs so they can dissipate all that heat. The voltage here, I just leave the 75 volt DC, but actually you can feed it with probably 95, 85, 100 volt DC. You can feed it with that voltage. It's not going to be any problem at all. And I decided to just to make sure that it's not going to damage the driver area of the PCB. I add this resistor 330 ohms to avoid damage to the main IPS or driver area of this resistor. I think should be a little bit larger, but on the simulation I was reading the current. It was not drawing a lot of current, maybe a few milliamps. This is the other one. I need to mark those. I forgot I had to do that. So this is the other one. I need to mark this. So this is the same. So let me do something here. I need to place a mark so I know those are part of the supply voltage of for the rail. Okay, right here. So this one here, and so I know. Okay, in case you are going to build this amplifier, you are not going to. Sorry about that. If you are not going to use larger, higher voltage, one example, you are going to use the original 75 volt DC. You can just place a jumper right there. You can just place a jumper right here across this resistor, and the other one you can just place a jumper. If you're not going sorry about that. If you are not going to use higher voltage, you can just place a jumper. One example, just a piece of wire. Place a piece of wire right here. I'm going to show you right now. Just a piece of wire right here. It's okay. It should be black. It should be black in color. There you go. Just a piece of just in case you are not going to use the higher voltage. If you are going to use higher voltage, I recommend to use the 330 ohm resistor. So this area of the circuit is not going to suffer the excess of current. of the supply voltage. So I'm going to show you the simulation yesterday. I was making some videos in Spanish, but probably most of you guys probably understand some English better than Spanish. Because all right, I think I have here the simulation. I think, yeah, I got a lot of stuff on my desktop. There you go. All right, this is the circuit. It's basically the same as this, the original schematic, about the same. The only difference is that it will have 4 more extra MOSFET pairs, and I'm going to change the supply voltage to 150 volts. I don't think it's secure, safe to do that, but just as an example, I don't think it's safe, but it's a really dangerous voltage, so I really don't recommend to do that. But actually, if you have a lot of experience and you know how to deal with higher voltages and you're not afraid of that, and you've been doing that for a long time, so you can do that as an experiment. So 150 volts is a really dangerous situation right there, so you gotta be careful. I would say go maximum voltage 95 volt DC. Do not go to 150 volt. That's a lot of power. It's a really dangerous situation. You gotta be careful right there. Right now, I'm going to, let's see. This is the power in watts meter. It's going to measure the output of the amplifier, and this one here will measure the AC. So I can do the calculation AC voltage of the output of the amplifier. So this is only 4 ohms low, working with 4 ohms low. And let's show you the oscilloscope. I'm feeding the amplifier with 1 kilohertz and 100. Let's go with 1 volt peak to see how much power we can get. I already made the video in Spanish, but today I will make it in English for you guys so you guys can see. All right, let's see. All right, I forgot to change the scale. All right, 50 volt. Okay, let's see. We have 457 watts, 1 volt peak. All right, I think I forgot to change the R16 to 33K because the other day I changed this resistor to 33K and I got a lot of power from this. Let me see. Let me see how much power we can get now. Okay, 33K. We have 626 watts. The voltage, the output voltage is 50 volts right now. 50 volts. So let's continue increasing the amplitude. Now we got 1 volt peak. 631 watt. All right, let's go with 1.1. Okay, 1.1 we have 764 watts. Okay, 1.2 we got 900 watts. 60 volt AC the output. Okay, 1.3 we have 8,000 watts. 1.4 1,238 watts. 1.5 volt peak, the amplitude, we got 1,419 watts. Okay, 1.6 volt peak, we got 1,616 watts. Wow, that's a lot. 1,600 watts, and it's still going. The voltage on the meter is 80 volts, so that's so 80 volts squared divided by the load is 1,600 watts. That's a lot of power right there. This is just a exaggeration. I really do not recommend it to do that, but you can actually work this amplifier with 95 volt DC just to keep it safe into the safe area. The only difference is that if you are using the 95 volt DC, you cannot increase the power that much, so it's gonna clip a lot faster. So let's see how it's gonna behave with just 95 volt DC on the supply voltages. Let's see. Okay, it's clipping right now, like I was saying. It's clipping at 600 and something watts. It's clipping. So I gotta go back. so before the clipping. So it's clipping right now a little bit. You can tell it's clipping because I only use in 90. But actually, with 8 pairs, I think you can go with 100 watt. I'm sorry, 100. I think 120 volts. I think 120 volts should be fine. I don't think it's gonna be 120 volts. Let's see how it's gonna behave with 120. Okay, 120 is a lot cleaner. We had 597 watts. Okay, let's increase the amplitude a little bit. All right, it's not clipping right yet. All right. Okay, we got one volt peak into the input amplitude. We had, okay, 630 watts. Let's increase the amplitude a little bit more to see what we can get with 120 volt DC. 1.2. We got 900 watts. 1.3. Okay, it's clipping right now. It's clipping a little bit. 1,000 watts. 1,000 watts. So yeah, you gotta work with the supply voltage. Probably 130 volt DC, but 150 volt is peligro alto voltaje, dangerous high voltages. It's a really dangerous situation right there. All right, guys, I'm going to stop the video. I will continue checking, making sure the PCB is correct. I gotta look at the original schematic to make sure everything is correct. It all is placed correctly into the PCB. The original layout is this one here. I'm going to show you. This is the original layout that I made a few years ago. Now I worked with this year. I just make some changes and stuff, make it look nicer. So this is the original layout, and the original files, they are right here. Probably you have not seen this amplifier before. I believe I have the files here. This is the original file. This is the original layout. The only thing I did is just clone it and make it, make it look nice. So this is the original PCB, and this is someone that made this PCB. This is some pictures of the original layout. Some other guys may also made this amplifier that you can see on these images. Really nice etching. Whoever made this etching is he's a master. Really good guy. A talented guy. So that's an AX11. Okay, so yeah, that's it. I'm going to continue here. I'm making sure everything is correct. This is before I cut the video, this resistor right here, this one here, it is the negative feedback. This is a really important resistor. You can change the value to probably 26K or 33K, so you can have more sensitivity into your amplifier. So for now, I just leave it at 22K as a default, and then later on you can replace it with a larger number, so to make it more sensitive. So I had to check all the traces to make sure everything is correct, like I'm doing right now. So I gotta do this, making sure everything is correct. You can see here, making sure all is correct. All right, guys, have a good day. I'm going to continue here, making sure this layout is correct before I share the file, and then I can share the file. I did not notice, to be honest, I did not notice that I can actually make a really large PDF file like the one that you see here right now. I did not know that, so now I know that I can share this really large PDF file, so you guys can create this PCB. Alright, guys, have a good day. I hope you like this video. Please subscribe to my channel, give a like to this video, and share the video for those who like electronics and stuff like that. Alright, guys, have a good day.